We have been solving quadratic equations for several days now. We have solved quadratic equations by graphing. We've looked at the square root principle. We've looked at factoring. So now we're going to look at another way to solve quadratic equations, and that's by completing the square. Now, you need to make sure that you have this vocabulary term in your notes, so please write this down. A method of solving quadratic equations, another one that we're going to be looking at, is completing the square. And what completing the square does is it turns every quadratic equation into this form. X squared equals C. Okay, now it's not going to look like this. This isn't going to be x squared equals 10. X will traditionally be a binomial like this one. But we're going to take trinomials that look like this, which we could add 7 to both sides. We could even subtract 9 from both sides, put this in standard form, and make it equal 0. But we can take this trinomial, this quadratic equation, and rewrite it like this. X plus 3 quantity squared, so there's my x squared. I have something, in this case a binomial, squared, equals 25. That's our equal C. And we're going to be able to do that by completing the square. Now, we're going to go through this first example, and you need to make sure that you jot down these formulas and these notes so that you know how to find C in order to complete the square. Okay, so what we're going to do is we're going to find the value of C that would make this a perfect square trinomial. Now, think back to when we had our special cases. Perfect square trinomials, that meant that I had a perfect square here, I had a perfect square here, and then my middle term had to fit that formula 2 times A times B. So think back to those special cases. So what we're going to do is we're going to find a way, we're going to look at a way to find C so that this is a perfect square trinomial.
Remember that a perfect square trinomial is in the form x squared plus b times x plus the quantity b divided by 2 squared.
Now this is taking...
The value of b is negative 16.
This is taking what we did with perfect square trinomials one step further. So I want you to have this. Please make sure this is written in your notes right here. To have a perfect square trinomial, to get C, to get that last number there, you take the value of b, divide it by 2, and then square it. Now think about this. If I take any number and square it, it will always be positive. Okay? Even if I start with a negative b, like I'm going to in this one, when I divide it by 2 and then square it using those parentheses, I will get a positive answer. So make sure you have this in your notes right here. To get a perfect square trinomial, to get the C value, I have to take b, divide it by 2, and then square it.
To make a perfect square trinomial, the term to add to x squared minus 16x is C, which is the quantity b divided by 2 squared. Substitute negative 16 for b in the expression, so C equals the quantity negative 16 divided by 2 squared.
All I'm trying to do is figure out, what do I add to x squared minus 16x? What's the C going to be? And I'm just using this really simple formula here to find that.
To solve for C, simplify within the parentheses. Then simplify the power. So C equals 64. Can C be negative?
All right, I just had this discussion. Can your C value be negative?
No. C is the square of a real number, which is never negative. Now it's your turn.
In order for us to be able to continue on with completing the square, you have to be able to find C in order to make this a perfect square trinomial. All right, so I want you to take this problem, use that real easy formula to find C, and determine what will the value have to be so that that is a perfect square trinomial. All right, your correct answer is 100. Hopefully this was really easy. You just take 20, divide it by 2, which gives you 10, and then you square 10, which gives you 100. So hopefully that was very simple. Finding C. Make sure you know this little formula here. Now we're going to look at another example. We're getting into problems where it doesn't really talk us through the example. So I want you to take as good a notes as you can, and we will review and discuss this when we get into class. I know when all of these notes come up at once, it can get kind of confusing. So please break this down a little bit at a time with me. Here's your trinomial, x squared minus 14x plus 16 equals 0. Well, first thing I want you to look at is this a perfect square trinomial? Well, this is squared, so that's good. Can I rewrite 16 so that it is something squared? Hopefully you're thinking the opposite of squaring is square root. You could take the square root. You could look at perfect squares, the list of perfect square factors that you may have. 16 is a perfect square, and it is 4 squared. Okay, so at first glance, this is a perfect square trinomial because this is squared, and this can be written as 4 squared. But then the middle term is our problem. If this is a 1x, thinking about just the base and not the exponent, just the base, it's an x. And over here, if this were 4 squares, if I just think about the 4, there's no way to get x and 4 and make it into a negative 14x. So even though the first and last term are okay, this is not a perfect square trinomial. So I'm going to bring all these up. Please, we need to take this one step at a time. The first thing that you're going to do, and you really need to write these notes down over here. This is, I know this is specific to this problem. You can make it generic if you need to in order to get the steps here for completing the square. But the first thing that they did was subtract 16 from both sides. That should be very simple. Take the C value, because it's not the one I need, it's the wrong C value, and move it over here. Make it negative 16. And then what you're going to do is find the real C value, the C value that actually makes this equation perfect square trinomial. 16 didn't, so I moved it over. Subtract 16 from each side. All right, so then use that b divided by 2 squared formula. Okay, well, what's my b? Right now it's negative 14. So take negative 14 and divide it by 2. And you get negative 7. And negative 7 squared is 49. So 49 is the real C value that I need. Okay, so I'm going to add 49 to my x squared minus 14x because that's the C value I should have. But think back to what you've learned even in middle school. What you do to one side of an equation, you have to do to the other. So if I'm going to add 49 to make this a perfect square trinomial, then I have to add 49 to the other side of my equation because I got to keep things balanced. Okay? Now, once you have written this as a perfect square trinomial, this is going back to factoring. This was in the last unit that we discussed. You're going to write this as a binomial squared. Okay? This is a perfect square trinomial, so that is x minus 7 squared. This is the factored form of this perfect square trinomial. And all of these problems, when you find the correct C value, will factor in that way. Okay, you'll have a binomial squared. So this is x minus 7 squared. Keep in mind that the 7 comes from the fact that 7 times 7 is 49, and 7 plus 7 is 14. So that's where that 7 came from. And it is a negative, it is subtraction because of that middle term. And then this one over here, that's not a big deal. Just take negative 16 and add 49. Okay, just a simple addition problem, you get 33. Now we've talked about this next step before. We talked about it in the in previous lessons. The way that you find, or the opposite of squaring something, is taking the square root. So if I'm going to take the square root of something squared, that just undoes, you're just undoing the operation. So I'm just left with x minus 7. Okay? The opposite of squaring is taking the square root. So that's just going to leave you with your x minus 7 because you're doing the inverse operation. But you also have to take the square root of the other side. Now, we've also discussed this, and this is not a new symbol. I have written it before. This is a positive or a negative because you have to remember that when you take the square root of something, You can get a positive or a negative solution. So go ahead and put that symbol there to help remind yourself so that you don't miss this at the end of the problem, that I am going to have two solutions, one positive and one negative, once I take the square root of my number. So this step is just to take the square root of both sides. All right, so I've taken the square root of x minus 7 squared. That's how I just get the x minus 7. It undoes that operation there. So that's still x minus 7, but I need to go ahead and approximate the square root of 33. So you can use your calculator, and it's about 5.74. So it's a positive 5.74 and a negative 5.74. Okay, positive or negative. And now, since there are actually two numbers there, one positive and one negative, I technically have two different equations. The first equation is x minus 7 equals, or is approximately 5.74, and the other equation is x minus 7 is approximately negative 5.74. So, since you technically have two numbers there and you have two different equations, write the two equations. Rewrite it so that you can see the two problems, two equations, and then solve for x. That's a very simple step. Add 7 to each side, so 5.74 plus 7. And then over here you also add 7, but this time you're adding it to a negative 5.74. And your two solutions that you get are 12.74 and 1.26. Those are the solutions to this quadratic equation. What that means, remember all the different terminology, solutions, roots, x-intercepts, zeros. If y is 0, x is going to be 12.74 and it's going to be 1.26. Okay? This is where your graph crosses the x-axis. And this would not be something you could see by graphing. Okay? In factoring, you're not going to be able to factor this trinomial the way it is and find your zeros. So the only way that you can solve this is by completing the square. So these are the steps. Now we are going to discuss more examples in class, but please make sure you have this example and the steps. That way when I give you a practice one to see how far you can get, you will have a guide on trying to solve that problem. Now, I do want you to attempt this one, okay? It's your turn. Think through those steps. Go back into the video if you need to. And try to solve this equation by completing the square. Now, I know this problem is going to take some while, so hopefully you paused the video and now you're coming back to check your answer. The correct answer to this is negative 6.79 and negative 2.21. And this is how you're going to solve it. Okay, you subtract the 15 from both sides. You complete the square. Now, what is very unfortunate about this one, what makes this one so much more difficult, is that when you divide 9 by 2, that's your b divided by 2, you get 4.5, and then when you square it, you get 20.25. So we're dealing with a lot of decimals here that traditionally you don't deal with a lot. So you're going to have to get used to seeing those decimals. They are going to appear quite often in this section and the next one. But once you get the 20.25, you have to add it to this side of the equation, and you have to add it to the negative 15. That's where the 5.25 comes from, when you add 20.25 to negative 15. 20.25 is a perfect square, even though it doesn't appear to be. 4.5 is the square root of 20.25. So this is the factored form of that trinomial. You take the square root of both sides. So we did that. Square root of something squared is just itself. You're just undoing that operation, remember, so you're just left with a binomial. And the square root of 5.25 is a positive or negative 2.29. And again, you have two different numbers here, so you have two different equations, one with a positive 2.29, one with a negative 2.29, and solve for x. Subtract 4.5 from both sides, and that's where your solutions come from. And we'll go over these more when you get to class.